to Math in Now. Today, we're doing Trigonometry, Chapter 1, Section 3, Part 1, the Coordinate Plane. I'm your host, Dr. D. Okay, so today, we're going to take Section 3 in two parts. So we're doing the first half of Section 3 in this lesson. This is the coordinate plane. Now what we do is we have our usual XY coordinate system, and we're going to draw a circle with the center at the origin. Now what we do is we draw a line segment from the origin, O, to a point on the circle. Now it could be anywhere on the circle. Now once we hit that point A, then we're going to drop a line segment down perpendicular to the x-axis, and that's AB, segment AB. So this gives us a right triangle OAB with the right angle at angle B. So angle AOB is in standard position. What that means is the initial side, OB, is on the x-axis, on the positive x-axis, and the terminal side is somewhere in the XY coordinate system. In this case, it happens to be in quadrant 1. But we're going to be dealing with the triangle when OA is in the second, third, and fourth quadrants as well. Okay, now, like I said, AB is perpendicular to OB, so that means that the measure of angle ABO is 90 degrees, or in other words, angle B is 90 degrees. It's a right angle. The measure of angle AOB, then, AOB is theta. So our angle in here is theta. Okay, this is the setup, and this is what we're going to be working with for a lot this whole year. Okay, so triangle AOB is a right triangle. Side OB is the adjacent side of angle theta. Then side AB is the opposite side. Now, the word adjacent means beside. So side OB is beside this angle. It's part of the angle. Now, side AB is not part of the angle. It's on the opposite side of the triangle from the angle. So that's why we call it the opposite side. Now, and the third side, side OA, is the hypotenuse. Now notice, side OA is always opposite the right angle. That's what makes it the hypotenuse. So, OB, adjacent, AB, opposite, and OA is the hypotenuse. Okay, so now we're going to introduce the trigonometric functions, which we call trig functions. The first function is sine of theta. Now sine of theta is opposite divided by hypotenuse. Now the opposite side is the y. The hypotenuse is going to be the radius of this circle, so we call it r. So sine of theta equals y over r. Now, the word sine is way too long, so we need to abbreviate it, so we just make it SIN. So that's much shorter, much easier. Okay, so when you see SIN theta in Bible class, that might be sin. Here, it's sine. Okay, so sine theta is y over r, opposite over hypotenuse. cosine theta is adjacent over hypotenuse. So cosine theta is adjacent over hypotenuse, and that is x over r. So we abbreviate cosine COS. And tangent theta is opposite over adjacent. Opposite over adjacent. So tangent theta, TAN, equals y over x. Okay, so those are the three major trig functions. Now, I know you've been taught in earlier math classes to remember sine, cosine, and tangent. You think SOHCAHTOA. I'm telling you, that's not a good way of remembering it. It may have been a good way of remembering it when you were brand new to it, but what I want you to do now is don't think of it as words, sine, cosine, tangent, but think of them as positions. So when you see the sine of an angle, you automatically think opposite over hypotenuse. You don't think the word opposite and the word hypotenuse. You just think, okay, here's the angle. I go blue over red. And cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you're not thinking about words, you're thinking about positions. And that's going to be much simpler later on. Now, if you insist on hanging on to SOHCAHTOA, then what you're going to end up doing is making your mind go in a longer route to get to what you need. So if you're going SOHCAHTOA, you're going sine opposite hypotenuse. Okay, opposite hypotenuse y over r. Well, that's too much. That's going to tire you out mentally, and it's also going to cause mistakes. So you need to learn this just quickly and easily, and it needs to become absolute automatic. So you don't have to think, which hand is my right hand, which hand is my left hand. You automatically know. Same thing here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, now, cruising onward. We have our triangle now, so we've got x is the horizontal component, y is the vertical component, and r is the radius of the circle, or the hypotenuse. Now, the terminal side of angle AOB is side OA. So, the slope of side OA is going to be the change in y divided by the change in x. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the change in y here is just the y value. The change in x is just the x value. So that means the slope of the terminal side here is y over x. So y over x is tangent theta. So that tells you the slope of the hypotenuse is always going to be tangent theta. All right, so here's our first example problem. Write the equation of side OA. So since OA includes the origin, the y-intercept is 0. So that means your linear equation y equals mx plus b just becomes y equals mx. All right, so write the equation of the line with the point xy on the terminal side. So here's my first example, is the point is 12, 15. So that means I go right 12 up 15 and I'm at my point that's on the terminal side of this angle. So I want the equation of that line that includes P that goes through the origin. So I know the slope is going to equal y over x, which equals 15 over 12, which equals 5 over 4. Yeah. So the slope is 5/4, and that tells me that the equation is y equals 5/4 x. Now, the only other thing that we need to state is the domain restrictions and the quadrant that P is located in. So clearly, it's quadrant 1. And the domain is going to be all x values such that x is greater than or equal to 0. Actually, just x greater than 0. Now, in your book, they actually do have greater than or equal to. In your book, the way it writes it is x is an element of 0 to infinity. Now, this symbol is an element of. The bracket means that 0 is included. And then the comma means it goes from 0 to something else. Now, it goes up indefinitely. So that means the right end is just infinity. Now, you put a parenthesis to close it because the parenthesis means that this value is not included. Well, there's no way infinity could be included because infinity is not a number. So this is the interval from 0, including 0, to infinity, not including infinity. And that's what x is an element of. So these two things say the same thing, and you need to learn it in interval notation as well. Okay, so let's cruise onward. So now we have the point 3, -4. So let's just draw what that looks like. 3, -4 is going to be right 3 and down 4. Okay, so now I want the equation of this line, where P is right here. So the equation of this line is going to be y equals mx, when the slope is going to be -4 divided by 3. So there's my equation, y equals -4/3 x. Now, this happens to be located in quadrant 4, and the domain restrictions, x greater than or equal to 0 again. And the other way we could write it is x is an element of the interval 0 to infinity. Okay, now let's try the point -2, -6. That means I go left 2 and down 6. So we'll just make this, here's my -2, here's my -6. All right, so this time I still have y equals mx, which means y equals m, which is -6 divided by -2, y over x. So y equals 3x. And notice, this is a positive 3 slope because it's going uphill from left to right. Now, notice one other thing. It's in quadrant 3. So what are my domain restrictions? Well, now x is less than or equal to 0. Or x is an element from negative infinity to 0. Notice we're saying it's less than or equal to 0, but we always state the interval from left to right. So how far left can this go to negative infinity? Notice I have a parenthesis here because there is no number that's negative infinity. And then I have a bracket here because it does include 0. So from negative infinity up to 0. All right, cruising onward. Next, we have our reciprocal trigonometric functions. So the original function, sine theta, if we reciprocate that, we have cosecant theta, and we abbreviate cosecant CSC. Then we have our cosine theta. If we reciprocate cosine, then we have secant theta, and that's abbreviated SEC. And then we have tangent theta. We reciprocate that, we have cotangent theta, and that's abbreviated COT. So notice we have sine is y over r. So that means cosecant is r over y. We have cosine is x over r. That means secant is r over x. And tangent is y over x. That means cotangent is x over y. Now, the easy way of remembering these reciprocal functions is you have the one word that has no co on it. It's matched with a word that has a co on it. So sine, cosecant. Cosine, well, now we want the word with no co on it. So it's secant. And then tangent, so the pair of that is going to be cotangent. So one has a co, the other doesn't. Okay, so what we want to do is we take a given point and we find the 6 trig functions on the terminal side of the angle. Okay, so let's do that. Here's our point 3, -4. Well, let's put it on the graph. So we're going right 3 and down 4. So 3, -4, and this would be 5 here, we know, because the Pythagorean theorem says that 3 squared plus 4 squared equals 5 squared. And we know it's a Pythagorean triple. So, and actually our angle theta, well, we'll look at angle theta is right here. All right, so sine of theta equals what? Opposite over hypotenuse. So it's -4/5. Cosine of theta equals what? Adjacent over hypotenuse. So it's 3/5. And tangent of theta is what? Opposite over adjacent, so -4/3. Now let's do the other 3, the reciprocals. So reciprocal of sine is cosecant. And that's going to be the reciprocal, so it becomes 5/4. And then the reciprocal of cosecant is secant, which the reciprocal of 3/5 is 5/3. And the reciprocal of tangent is cotangent. And the reciprocal of -4/3 is going to be -3/4. Now notice I didn't write 3 over negative 4 just because 3 over negative 4 is the same thing as negative 3/4 anyway. So that's it. There are your 6 trig functions. Now, the key thing for this lesson is to learn your sine, cosine, tangent, secant, cosecant, cotangent instantly and make it automatic. If you do this, then you're going to be in great shape for the remainder of the year, because this is a key in this whole thing. So you need to absolutely get that down so you don't even have to think hard about it. Okay, that's it. Have fun with these.
That's all, folks.